Good morning. My name is Harjinder Singh Khalsa. I am currently pursuing MCA from International Institute of Professional Studies. Today we are discussing about test 1 questions of subject theory of computation. The question given to us is we have to create a automata. We have to construct a finite automata to accept the language set of words, set of strings that ends with 010. So before solving this, let me tell you about little about finite automata. Finite automata is a machine that in which we feed input and it changes its state based on the input. And when the string ends, if the machine is on the final state, or we call final state, then the string is accepted. If it is not on the final state, then the string is rejected. So finite automata is a 5-tuple which contains q, sigma, delta, q0 and f. Q are the set of states, sigma are the input symbols 0 and 1, delta is the transition function or mapping function, q0 is the initial state, and f is a set of final states. So to generate the finite automata for a string ending with 010, I have created here a finite automata which contains 4 states, q0, q1, q2 and q3. q0 is the initial state and q3 is the final state. And based on the input, it changes its states. So I have used JFlap. Let me share the screen. So I use JFlap to simulate the finite automata. Test. So as example, let's take input 10010. So as first it encounters the 1, string is given is 10010. So first it encounters the finite automata encounters 1. Then it states as q0 as there is a self loop on the q0. The next symbol it encounters is 0. So it will move to q1 state. Then next it again encounters 0. So it remains at q1 as there is a self loop for q1. Then it encounters 1. So it moves to q2. And at last it encounters 0. Then it moves to q3. And as the string is finished and the finite automata is on the final state, so the string is accepted. Let's test with a string which does not contain 010 at the end. Let's take 10011 this time. First it encounters 1, it remains at q0. Then it encounters 0. Then it move to q1. Then it encounters 0 again. It remains at q1 as there is self loop on q1. When it encounters 1, it changes to q2. And it encounters 1 again, so it will move to q0. As the string ends and finite automata is not on the final stage, therefore the string is rejected. Let's move to the second question. The second question was to construct a PDA for the same, which is PDA. We have to construct PDA for string ending with 010. The PDA pushdown automata is more powerful than finite automata. It is a 7-tuple. It contains q, sigma, tau, delta, q0, and stack symbol we can call this z0 or lambda, and f. Q are the set of states, sigma are the set of input symbols, tau are the stack symbols symbols that we can insert on the stack. Delta is the transition function, q0 is the initial state, Lambda is the stack symbol which represents the end of the stack. You can also use Z0 instead of lambda. And F is the set of final state. As in a question, we are asked string end with 0 1 0. So we do not need to check any pattern. And as we do not have to check any pattern, we can directly make a PDA like finite automata, and we do not have to insert anything in the stack. We can just change states based on the input. I've also emulated it in the JFlap. Let me share the screen. So I have created a PDA here for the string. PDA that accepts the string that's end with 0 1 0. Let's take an input 0 1 1 0 1 0. So as it PDA encounters 0 first in the string, it changes to Q1 and does not insert anything in the stack. And then it encounters 1. It moves to Q2. Then it encounters 1 again. So it moves to P0 again. And then it encounters 0. So it will move to Q1 again. Then it encounters 1. So it will move to Q2 again. We are not inserting anything in the stack and we do not require to match any pattern. Then it encounters 0 again. It will move to Q3, and as the string is finished and the PDA is on the last final state, so the string will be accepted. Let's test with a negative string that does not contain 0 1 0. Zero one one 0 1 1. Let's test with it. So as in 0 1 1, it first encounters 0, then it will move to Q1, then 1 and it will move to Q2. Then it encounters 1 again, so it will move to Q0. Then it encounters 0, so it will move to Q1 without inserting anything in the stack. Then it encounters 1 again, so it will move to Q2. And as it contains 1 again, so it will move to Q0. As the string is finished and the PDA is not on the final state, therefore string is rejected. Let's move to the third question. Let me share the screen again. The third question was to construct a Turing machine for the same. You have to create the Turing machine for the string that ends with 0 1 0. Turing machine is more powerful than finite automata and PDA. It is also a 7-tuple which contains Q sigma, T, delta, Q0, blank symbol, and F. Q is the set of state, sigma is the set of input symbol, T is the tape symbol that we can change or write or read from the tape, delta is the transition function, Q0 is the initial state, B blank, we can also use B here, or the blank symbol, which represent the blank symbol end of the string or start of the string. Then we have F, which is the set of final states. Here I have designed a Turing machine that accepts 0 and 0. It is same as finite automata, as we do not need to check any pattern. We can just move to the end of the string, and when we encounter blank, we move back, and if we are staying on the final state at the end of the string, then it will be accepted, otherwise it will be rejected. And let me show the JFlap emulation for this. Here's the JFlap emulation for a Turing machine that accepts string 0 ends with 0 1 0. Let's try running it. 0 1 0 1 0. So as we can see, it encounters 0 first, so it will move to Q1. Then it encounters 1, so it will move to Q2. Then it encounters 1 again, so it will move to Q0 again. Q3, sorry, it will move to Q3. Then it encounters 1, so it will move to Q2 again. Then it encounters 0, so it will move to Q3 again. Then it encounters the blank symbol, which represents the end of the string, so it will move to Q4. As the string is completed and Turing machine is standing on the final state, so the string is accepted. Let's try a negative. Let's try a string that does not contain 0 1 0 at any. 0 1 1 0. Okay, so as you can see, for 0 it will move to Q1, it will move to right, does not change anything. It will change 0 to 0 and move to right. At Q1 it will change and it counters 1, so it will change 1 to 1 and move to right again. At Q2 it will move to right again by changing 1 to 1, as it encounters 1 again, so it will move to Q0. At Q0 it encounters 0, so it will move to Q1 by changing 0 to 0 and move right. At Q1 it will encounter 1, so it will move to Q2 with 1 changing 1 to 1 and moving right. As it encounters 1 again, it will change 1 to 1 and move right at Q0. And then it encounters blank symbol, as there is no output state for blank symbol. The Turing machine will be stuck at Q0 and the output will be rejected as the string ends. Let's move to next question. In next question, we have to construct a Turing machine to accept the language 0 1 star plus 1 0 star. For this, I have created a Turing machine. I have also simulated in JFlap. Let me show you the JFlap screen to explain you more about it. So as you can see, this is the Turing machine that will accept for 0 1 star plus 1 0 star. That is a string that start with 0 and end with 1 and having 1 after 0. First symbol will be 0 and after every string and everything in the string contain 1. Or the string start with 1 and all the other elements it contain letter is 0. Try with 0 1 1 0 1 0. As it is starting with 0, but it does not contain 1, all it doesn't contain everything is 1 on the right side, so it will be rejected. As you can see, for 0 it will move change to 0 to 0, then move right. At 1 it will move to 1 to change 1 to 1 and move right again 1, so it will remain at Q2 changing 1 to 1 and moving right. As it encounters 0 and there is no state for 0 on Q2, output state for 0, the Turing machine will be stuck at Q2 and the output is rejected. Let's try with this accepting string. Let's test with 0 1 1 1 1. For 0 it will move from Q0 to Q1 by changing 0 to 0 and moving right, and at Q1 it will change 1 to 1 and move right again and move to Q2 state. And at Q2 state it will there is a self loop, so it will accept all the ones and stays at Q2 by changing 1 to 1 and moving right. Q2 Q2 and again Q2. Then when it encounters blank symbol, it will move to state Q5 and move left to represent the end of the string. And as the string is ended, and Turing machine is standing at Q5, so the out string is accepted. Let's move to next question. So next question is to construct a pushdown automata A equivalent to the following context-free grammar. So the grammar is given to us and we have to create a PDA for this grammar and test whether this string 0, 1, 0, 0, 0, 0 is accepted. Q. Input set of impulse symbols will be 0, 1. How represent the stack symbol? We will insert only S, B, 0 and 1 in the stack. And delta is the transition function. Q is the initial state, also final state, and as the start symbol, if I represent the end of the stack. Delta is defined by the following rules. As we can see, we are given 4 rules. We have defined 4 rules for representing this grammar. The first rule is if we can at initial state, if if stack contains S, the start symbol, we can replace S with 0BB. 0 is the terminal and B is a non-terminal. S is also non-terminal. And rule 2 defines that if we initial state, if any state, if the stack contains B at top, then we can replace B with 0S, 0, 1 or 0. Rule 3 defines if we encounter the 0 in a string and top of the stack also contains 0, we can pop the 0 out of the stack. Rule 4 defines if we encounter 1 in the string and the top of the stack is also 1, we pop the 1 from the stack. So now let's test this 0, 1, 0, 0, 0, 0, which is 0, 1, 0 to the power 4 string, and see if it is accepted by our PDA. So as we can see, we are given Q 0, 1, 0, 0, 0, 0 or Q 0, 1, 0 to the power 4 and S as the starting state, which is already in the stack. So by rule 1, we can replace the S with 0BB. We have rules here for reference. And next we will apply rule 3 as we have 0 on the top of the stack and we encounter 0 as the first string first letter. So we pop the 0 from the stack as we can. Then by rule 2, as we can replace B with 1S. We'll replace B with 1S. Then again, as we can see, we encounter 1 and top of the stack also contain 1. So by rule 4 again, we can pop 1 from the stack. Now the stack contains SB and remaining string is 0, 0, 0, 0. So we can replace S again with 0BB by rule 1. Then as again we are seeing we have a 0, we encounter 0 in the string and also the top of the stack also contains 0. So we pop the 0 again by rule 3, by applying rule 3. Then as we can see, we contain 3 B's and there are 3 zeros in our string remaining. So by rule 2, as we can replace the 2B with 0, we will change all the B's in the stack 0, 0, 0. And by applying rule 3, which says if top of the stack also contains 0 and we encounter 0, we will pop the 0. 3 times we apply this rule and the stack will be empty and the string is also empty. When both are empty and PDA, if both are empty, PDA will accept the string. As we can say that 0, 1, 0 to the power 4 is a subset of our PDA, which is accepted by our PDA. Thank you.